We create and save files every single day. Photos, documents, you name it. But have you ever stopped and wondered what's actually happening inside the machine? Today, we're going to follow one simple photo on its incredible journey, all the way from a single click to its final home in long-term storage. Let's just dive right in.
Ah, the Save button. It seems so simple, doesn't it? Just one little click. But pressing it kicks off this lightning-fast, totally invisible dance of digital processes inside your computer. And by the end of this, I promise you'll understand every single step of that complex choreography.
So, every journey has to start somewhere. For our digital file, that beginning is all about perception. Before a computer can remember anything, it first has to receive that information from the outside world. And this is where its senses, what we call its input devices, come into play.
A computer has a bunch of ways of sensing the world around it, right? It can feel your fingers on a keyboard, it can scan the lines of a barcode, or it can read the data off a credit card. For our photos journey, though, it all starts with the webcam. That device's entire job is to capture light and translate all that visual information into the only language a computer understands, ones and zeros. And just like that, boom, the data for our photo officially exists.
Okay, so our photo has been born. It's basically just a long string of data. But where does it go first? Well, before it gets filed away permanently, it needs a temporary place to kind of hang out while the computer is actively using it. So, welcome to the digital workbench.
This workbench is called RAM, or Random Access Memory, and you can just think of it as your computer's short-term memory. It's incredibly fast, which lets the processor instantly access that photo data if you, say, want to edit it, or even just look at it on your screen. But here's the catch. It is a temporary workspace.
And this is where we see the really crucial difference between RAM and another type of memory, ROM. See, RAM is volatile, which is just a fancy way of saying it has amnesia. The second the power goes off, poof, it forgets everything. It's the active workbench. ROM, on the other hand, is non-volatile. It's like the computer's permanent instruction book, holding all those essential startup directions it can never, ever forget. So right now, our new photo is kind of living dangerously on that volatile RAM workbench.
And this is the moment we've been waiting for. You click Save. That one single command tells the computer, hey, take this precious photo from the temporary workbench and move it into the computer's long-term memory. We're officially moving it into the great digital library.
Now, this digital library has a few different wings, and each one is built on a really unique technology to store information permanently. The three main types are magnetic, optical, and of course, the one most of us use today, flash storage. Each one writes the story of our data in a completely different way. So first up is magnetic storage. This is the technology behind traditional hard disk drives, or HDDs. I want you to imagine a tiny needle just flying over a rapidly spinning record. But instead of carving grooves, it's magnetizing microscopic little spots on the disk, creating a pattern of on or off states. This pattern of magnetism is literally how the ones and zeros of your photo get stored.
Then you've got optical storage. This is the tech in your CDs, DVDs, and Blu-rays. It uses a super high-powered laser to etch these tiny pits onto the disk's surface. Now, to read the data, a lower-powered laser scans them. A flat area, what they call a land, reflects the light back, and that's a 1. A pit scatters the light, and that's a 0. It's a really clever way of using light itself to encode information. And when you look at this timeline, the evolution of storage is just astounding. I mean, in the 50s, we had these huge magnetic tapes. The 70s brought us the floppy disk. Then the 80s and 90s were all about optical disks like CDs and DVDs. And finally, in the 2000s, we saw the rise of flash storage, which gave us the solid-state drives, or SSDs, that are pretty much standard in most computers today.
So, what's the actual difference between an old-school HDD and a modern SSD? Well, an HDD has moving parts, kind of like a record player, which makes it slower and way more fragile. An SSD, on the other hand, uses flash technology, so it has 0 moving parts. The speed difference is, it's like trying to find a specific sentence by flipping through every single page of a book. That's the HDD, versus just instantly remembering it from memory. That's the SSD. It is a total game changer for how fast your computer feels. Okay, so our photo is now securely stored in the computer's long-term memory. It's safe. But what good is a photo if you can't actually see it? The final leg of its local journey is to travel from that storage drive back to us through what we call output devices.
This is the job of output devices.
The ones and zeros of our photo get pulled from the storage drive, they're processed by the computer, and then they're translated into something we can actually understand. This could be pixels on a monitor, ink on a page from a printer, or even an interactive image on a touchscreen, which is really cool because it's both an input and an output device.
But of course, in our modern world, our file's journey often has one final chapter. We don't just store things on our own local devices anymore, do we? We upload them to the cloud.
So what is the cloud, really? It sounds all magical and floaty, but it's actually very, very physical. When you upload our photo to a service like Google Drive or iCloud, you're really just saving it on someone else's computer. More specifically, you're storing it on a massive network of physical hard drives and SSDs in some data center somewhere in the world, all working together to act like one single gigantic drive that you can get to over the internet.
And the trade-offs are pretty clear. On the plus side, it is incredibly convenient. You can get to your files from anywhere, on any device, and sharing is a breeze. The downside, well, you're totally dependent on your internet connection, there can be subscription costs, and you're essentially trusting another company to keep your data safe and always available.
So, from a simple flash of light in a webcam, to a temporary state in RAM, to a magnetic pattern on a spinning disk, or an electrical charge in a silicon chip and a data center maybe 1,000 miles away, that is the incredible journey of a single file. It really makes you think, though, as our personal digital libraries expand to hold thousands and thousands of photos, documents, and memories, which one of them is so important to you that you'd want its journey to last forever?